What's happening, everybody? It's your boy Creative. Go ahead, say it with me. We are back at it again to do what? To create something great. Now, I'm not going to hold you. I'm super excited what I have planned for y'all today. We're going to be going over backtesting, how to properly set up a backtest in Python, how to run a backtest for your option algo strategies, right? And some of the steps that you would want to take before you even run your backtest. So if you haven't already, go ahead and smash the like and subscribe button. So let's go ahead and get into it, right? So first things first is that I want us to understand what is a backtest, right? So a backtest is being able to take your algo strategy, right? Drop it off in a time machine, and you want to see how well it performs on historical data. Now, the school of thought is that if the backtest does well and on historic data, that it will do well on present or the future data, right? Quote unquote. But the thing to keep in mind is that there's no guarantees. Now, just because a backtest performs well in the past doesn't mean that it's going to perform well in the future, right? Now, that there's three different types of backtests that I want us to understand. There's an event-driven backtest. This is going to be the most realistic. It simulates every tick, and Quant Connect uses this, right? But this is the most complex to build, right? So for those that aren't familiar with Quant Connect is, here we go. I don't want to show you the pricing. So Quant Connect is a platform that allows you to research, backtest, and trade your investments, right? Now, it is a good platform to use, but sometimes it's not as customizable as I would like with regards to using it. And here's some of the pricings for those that are interested, right? So for a researcher, what you're going to get is the local coding that you can use in Visual Studios. All right, bet. Extended database, right? So this is something that definitely makes sense. You don't have to go searching for the data. The data is already included into it for 60 bucks a month. That is not bad, right? I get my data from Theta Data, right? So we're going to be using a little bit different. Oh, they changed their website. But this is where I get my data from when it comes to option data. Quant Connect isn't bad, right? But the only thing I would say is like it's not as customizable as I would want, right? Then there's also a vectorized backtest. That's going to be a backtest that uses NumPy. NumPy is a Python library that is going to be Python's calculator, right? So whenever there is a new Python library or a package that I want more information on, I go to pypy.org. You get it? Because it's pi. So I go to pypy.org. This is the official repository, official website in order to search and find any Python packages, right? So what we're going to do is put NumPy and then Pandas. The difference between the two, NumPy is going to be the calculator for Python, and then Python's is going to be Python. Pandas is going to be the Excel for Python. You put those two together, you're going to have a vectorized backtest, right? Where you can run the entire strategy in one array. It's fast, and this is what I use for my fleets, right? And there's also a for loop background, and this is object oriented. It's the middle ground for the two. But let's first look up NumPy. So NumPy, hit enter. And then we see NumPy right here. The thing I love to look at is that, all right, bet, are you constantly updated? You see here it was just updated a few weeks ago, March 29th, 2026. So let's go ahead and click on NumPy. So NumPy is a fundamental package for scientific computing with Python. It provides n-dimension array objects, sophisticated broadcasting function, tools for integrating C and C++. If that's your engine, you can definitely use it here too. And then foreign code uses linear algebra, Fourier transformation, and then random number capabilities, right? So NumPy is a community-based open source project library developed by a diverse group of contributors. NumPy leadership has made a strong commitment to creating an open, inclusive, positive environment. You can read more on this here. So NumPy, again, I know all these fancy words sometimes can get a little bit mixed up, but NumPy is going to be the calculator for Python, right? Then we also have Pandas, and this is how we're going to install it, is pipping installing NumPy. Now we also have Pandas. So Pandas is going to be the Excel for Python, right? You see how both of them are a little pretty. So a powerful Python data analysis toolkit, right? So Pandas is a Python package that provides fast, flexible, and extensive, data structure designs to make working with rational or labeled data both easy and intuitive. It aims to be fundamentally high level building block for doing practical real world data analysis in Python, and additionally has a broad goal for becoming the most powerful, flexible, open source data analysis manipulation tool available in any language. And it's already well on its way towards that goal. This is pandas, right? So we're going to using, this is what I do. I do vectorized, where I'm using pandas and NumPy, right? Where I'm running each strategy through an array, and we want to be able to gauge how well it works, right? Now, one thing that I want us to understand is, hold on, let's actually go look at, now before we actually run a strategy, right? We have to make sure that the environment is ready to go. That there's everything that the environment needs in order to proper run, right? So I created this file that we can run within our conda environment. This is going to be the back test, but let me actually get, no, bruv. All right, bruv. I love it. Bruv. All right, 2 seconds. Let me just do this way since you want to do that. We're going to create a new file. Then we're going to call it bt env check.py. Boom. So what this file is going to do is going to check all the packages required for fleet backtesting is installed and the minimum versions, right? We're going to run this before any backtest session, right? So the exit code is going to be 1 if the environment is not ready. So it's checking for DuckDB, right? DuckDB, again, we're going to go here, DuckDB. DuckDB is a fast in-process, portable, open-source analytical database system, right? DuckDB is a simple to install, deploy. It has 0 external dependencies, and it runs in-process to its host, right? So what it does, it allows me to be able to go through all of the data that we have for option data, because when you're using option data, especially across multiple years, it can get quite dense, and DuckDB allows us to be able to sort through that data a lot faster than using just pandas, right? Then we're going to have PyArrow. For those that are not familiar, let's go ahead and search up PyArrow. So what PyArrow does, this library provides Python API the functionality to provide Arrow C++ libraries along with tools for Arrow integration and entropy with pandas, NumPy, and other software in the Python ecosystem. What we're also going to be using is QuantStack. QuantStack is going to be for our tear sheet, and the tear sheet is going to have the Sharpe ratio, right? What is the Sharpe ratio? The Sharpe ratio is is going to be the benchmark in our head that lets us know if the strategy is going well, right? A Sharpe ratio between 1 and 2 is extremely good. A Sharpe ratio that is above 2 is phenomenal. Those are like hedge fund like levels, right? And what I aim for when it regards to my Sharpe ratios for the back test, anywhere between 0.75 and 1. I mean, anything greater than 1 is like, all right, bet it's working. But again, I'm not looking for really anything above 2 because those are hedge fund manager levels, right? And above 3, you really got to look at your numbers just to make sure that you properly are doing this correctly, right? And another thing that's going to be in this tear sheet is going to be a drawdown. So the drawdown is going to let us know from peak to trough. Basically, what is from the highest point to the lowest point, right? What is the amount of the money that the strategy has lost? Then we're going to have the annualized rate of return. Then we have Pandas TA. This is going to include our technical indicators such as VWAP, RSI, ATR, Y finance if we need for fallback data, then mplot_lib so we can see our equity curve. So what we're going to do is actually run this to make sure that it's Gucci dem. I'm going to open up a terminal. First things first, and then I want to get our conda environment within the terminal, and the conda environment is going to be like the garage that we have for our particular strategy, for our particular backtest, right? To make sure that all of the Python packages that it needs are within that conda environment. So I'm going to go ahead and run the file. Let's make sure that we're Gucci dem. So we have DuckDB, we have Pandas, PyArrow, NumPy, all the packages are ready, and we're ready to go for this backtest. So what I need you to do is go ahead and stick around for the next video, because what we're actually going to be doing now is running the back test, right? And talking a little bit more about the strategy that we're creating and how to properly create this vectorized back test, right? Using NumPy and Pandas, DuckDB, and a few other these packages that you see here. So if you haven't already, go ahead and smash that like and subscribe button. It's your boy Creative. I'll be back at it again with another episode.